Hello my dear, today I am discuss about the GATE previous year question. Okay, CPU scheduling related. So what is actually my question? Consider the three process P1, P2, P3 shown in the table actually process ID, arrival time as well as given time unit required. Okay. So what is the actually main case? So the completion order of the three process under the policy of FCFS and RR2. So my question is based on the FCFS, that means first come first serve and round robin algorithm. Okay. So sir, what is the meaning of RR2? We also know that RR means round robin. Sir, what is the meaning of 2? That means CPU take time quantum 2 minutes or 2 seconds, just 2 times actually. Okay. So in this case, this is the means 2 times. Okay. We also know that for each and every CPU scheduling algorithm, there are two most important things. Most important things is actually one is criteria, and another is mode. Okay. Each and every scheduling algorithm have one criteria. Okay, which belongs to actually which criteria? That means arrival time, okay, time quantum, burst time or CPU time. So in this case, for FCFS, first come first serve, criteria is arrival time, and mode is non-preemptive. Okay, so this is actually important. So what is criteria of the FCFS algorithm? Arrival time. Okay, we just assume that with respect to arrival time, okay, whose arrival time is less, those process will be soon participate. And mode is non-preemptive. Sir, what is the meaning of the actually non-preemptive? That means if one process will be executed until the finish of this process, not chance or not passing another process. Okay, so that is the means non-preemptive. So the criteria of the FCFS is arrival time and non-preemptive. So first of all, I am solving the question with respect to FCFS, then go to the round robin algorithm with CPU time quantum 2. Okay. So my Gantt chart. What is my Gantt chart for FCFS? Sir, what is the Gantt chart? Gantt chart is the most important for CPU scheduling algorithm. Without Gantt chart, it will not be happened or not be possible to be solved. Okay, it's actually very difficult to be solved. So that's why Gantt chart is actually needed or required for implement this algorithm. Okay, so my process ID 0. So first of all, now that each and every scheduling algorithm with Gantt chart with starting 0. Okay, why? Because process ID will be started with 0 and I am checking with arrival time which process are actually arrived in this time with respect to 0. Okay, like an example for simplicity, so you are go to the bank, okay, and bank manager are serve the actually work with the which actually come first. Okay, first come and served first. So at 12 o'clock, which person, how many person will be entered to the bank? First of all, bank manager see. Okay, and similarly, I am say that in arrival time, how many process will be arrived at 0 location? Okay, so they are having one process will be arrived or present in 0 times. So that is P1. So P1 process are actually arrived in this time. Okay, arrived in this time. So that's why I am just writing P1. And what is the time unit required of the P1? So 5. That's why I write the 5. Why 5? because we also know that the mode is non-preemptive. First of all, which process will be executed? So those processes actually execute for full timely or completely, not context switching in between and to perform another process. That means preemptive. So that's why the, as a FCFS follow the mode of non-preemptive. So that's why first of all to be complete one process completely entirely, then to be perform another process. Okay. And next time 0 to 5, how many process to be present in the 5 time? There will be two process, P2 and P3, P2 and P3. Okay, within 5 times at 5 o'clock, how many person will be are present in the bank? Okay, P2, P3, because P2 person are present actually one time 1 o'clock, and present person 3 actually are present 3 o'clock, 3 a.m. actually. Okay, so that's why I am just writing two processes are present in this time. So which process actually execute first? Which process actually execute first? Also now that for FCFS are based on the arrival time, which arrival time is less, those processes actually execute first. Within P2 and P3, which arrival time is actually less? Sir, 1. Okay, so that's why P2 will be arrived first and perform entirely tasks within 7 times, that means 12. Okay, next P3 is remaining. Okay, so P3 time quantum 4, that means 16. That means 16. Okay, that means 16. So my question is actually the completion order of the 3 process under the policy of FCFS. The completion order. Okay, so what is my order to be completed? So first of all P1 complete, then P2 complete, then P3 complete. Okay, so P1, P2 and P3 is the order to be completion of FCFS scheduling algorithm. Okay, so there will be two options FCFS P1, P2, P3, P1, P2, P3. We cannot determine which actually the right option because both are same. Okay, so that means two are right but not. Why? Because my question is another the completion order of the 3 process with the respective of round robin algorithm. So now we find the round robin algorithm which quantum time actually 2. Okay, so first of all round robin algorithm is to be nature is a cyclic method. Okay, and context switching is performed in this case because their mode is actually preemptive. Okay, their mode is actually preemptive. So for RR2, what is the criteria? What is the criteria? Criteria is time quantum. Time quantum and mode is preemptive. Mode is preemptive. Okay, that is preemptive. So first of all, I am say that round robin algorithm is the most important as well as starvation free algorithm because other remaining FCFS, okay, SJF, SFTF, HRTN, all of the actually scheduling algorithm are fixed. Starvation may or may not be, but round robin algorithm is most faster and most reliable other than scheduling algorithm. Okay. So time quantum and preemptive. Criteria is time quantum and mode is preemptive. Preemptive means it can to be chance another process to be performed. Okay, without not entirely completed one process. That means if one process is continue, another process can perform, and then P1 will be remaining part will be a continue. Okay. So now we create the Gantt chart. Okay. But one most important thing in round robin algorithm there will be one extra Gantt chart or extra queue, that is the called ready queue needed. Ready queue are needed. Why, sir? Because in this case they have been needed context switching, so that's why ready queue will be needed, and as well as running queue, all of the scheduling will be needed. So what is the, sir, ready queue in the base of? What is the, sir, ready queue? এত জোরে গল্প বললে না হবে এক প্রশ্ন। What is the ready queue actually? So process 0, at process 0, which is actually are performed at process 0, P1, P2 and P3. So at 0 position, which process are actually present or which process are actually ready to perform the ready queue? Okay, so P1. So that's why I am just create P1. Okay, then my running queue actually chart, Gantt chart 0, P1. Sir, P1 are continuing how many times? 2 times, because we also know that the time quantum is 2. Round robin algorithm, most important things is actually time quantum. Okay, so time quantum is 2, that's why it's continuing 2 times. Okay, it's continuing 2 times. So that's why I am just write 3. Why? Because 5 will subtract 2, then 3. Now I am see that at 2 times, at 2 p.m. how many person will be present at bank, in bank? Okay, so at 2 positions, how many processes are actually performed? P2. Okay, P2. So P2 will be right in the ready queue. P2 will be right in the ready queue. First of all, I am check how many processes are present in the ready queue. Okay, so that's why, and then check P1 process is complete or not. Yes, not, because 3 is remaining. Then we will be mentioned at the last of the ready queue. Then P1 is removed because P1 work is complete. Then P2 will be performed. So P2 continuing 2 times, because all of the times time quantum is 2. Okay, so that's why 5 is remaining. So why? Because 2 times will be needed. Okay, 2 times will be needed. So now I am just write 4. Sir, at time 4 o'clock, how many person will be present in the ready queue or the bank? So 3 are actually ready. Both of them are actually ready, so that's not matter. But newly P3 process 3 are actually ready at 4 p.m. So that's why first of all we just write P3. Okay, first of all, which process actually are ready? Okay, those processes will be right, and then check P2 process is complete or not. First of all, at 4 p.m. or at 4 a.m. how many processes will be are actually present in the ready queue? Okay, that mentioned. And next time P2 processes are complete or not. Check. Are complete? No. They have a remaining 5 actually time. So that is not complete. So that's why mentioned at the last. Okay. So P2 will be removed because P2 is work is completion. Now P1. Sir, P1. Okay. P1 continuing 2 times. That means 2 times means 1. Sir, why? 3. Subtract 2 from 3. That means 1. Okay. 3 minus 2. That means 1. Okay. I am just right. Sir, within 6 times, how many processes will be present? So there will be 3 processes. All of the processes will be performed in the ready queue. So there will be no remaining any process. So that's why we don't worry about another process will be performed or not this ready queue. So now we will be check P1 process work is completion or not. Yes, remaining 1 time. That means it's not complete. So that's why I am write more time. Okay, at the last of the queue. Okay, P1 is removed. So next time P3 is performed. Sir, P3. Sir, what is the P3 value? 4. Okay, so 2 is cancelled. That means 2 is remaining. So P3. Okay, now check it 8 times. How many processes will be are actually present? Okay, all processes are executed one time, so there will be no any process remaining process. So don't worry about remaining process, and check the second condition. The P3's work is complete or not? Yes, not, which is remaining. So P3R will be here. P3R will be here. Okay, P3 is done. Okay, now I am right P2. Now I am right P2. Sir, P2 actually 5. Okay, that means 3 are here, 10. Okay, how many processes are actually present in the process? Same type, there will be no any process, so don't worry about the process are present. Okay, I am just checking the second condition, the actually P2's process to work is completion or not, because 3 is remaining, so then P2 will be are present in the ready queue. Okay, now P1, sir, P1 completion 1, so that means 11. Although time quantum is 2, but have remaining 1 time, so that's not matter. Okay, just put the value. Okay, P1 is cancelled. Now you check P1 works is complete or not. Yet until the value of the 0. Yes, the value of P1 is 0, so that's why P1 process 1 work is completion. Okay, so that's why P1 is cancelled. Okay, now remaining P3. Now remaining P3. So P3 process is actually 2, so that means 0. So that means 13. Sir, remaining P3 process any work? No, because this is 0. Okay, we continuing another process P2. P2. So P2 have 3. Okay, P2 have 3. That means 2 is subtract from 3 and 15. Okay, we check another time how many processes are actually present in the ready queue. All processes are completed. So first condition not check. Second condition, P2 is completion or not, because 1 is remaining. So P2 are remaining. Although we just write at a time, but for simplicity I am just another time. Okay, so P2 is 15. Yes, this is the 0. Why? P2 5 is not completion. That's why I am again write another time. Although if you not write, so that's not problem. But for simplicity, I am write another time. Okay, so P2 is P2. Okay. Now the completion order of the 3 processes under the policy of FCFS is P1, P2, P3 also now that. So one answer is actually right, but we confuse from 2 options because both are actually same options for the respective of FCFS algorithm. But to be find the best result or the correct result, now check the completion order of the round robin algorithm with quantum time 2. So what is the completion time of round robin 2? Scheduling algorithm, what is the completion time? So which is actually completion first in this ready queue, in this running queue, which is actually completion first? Which is actually completion first? Just checking which is actually completion first. Okay, P1, P2, P1 continuing another time, P3, P2, P1 are here in the remaining time, not. P1 are complete at the time 11. So P1 complete first. Then check P3 are complete another time rest, no, for after P2, because P3 is completion second, and then P2. So the completion time of the round robin algorithm is two, actually P1, P3, P2. So P1, P3, P2. So that's why B is the correct option. I hope that you can understand this method, which is very easily. Okay. So this is the Thank you for everything.